Welcome to eDNA Tech. In this video, we are going to see how to interface 8 LEDs with only one pin. So basically for that we need a shift register. What is shift registers and how they are made? So shift register is nothing but a D flip-flop that are interconnected one another to make a shift registers. So basically D flip-flop is nothing but it has a one input pin and one output and one clock signal. So whenever the clock is high, what is in the data pin will be sent out. So if we give an input of 1, when the clock is 1, then the output will be 1. If the clock is 0, there is no output in this D out pin. So basically D flip-flop will latch a value when the clock is on. So likewise, one or two are depending upon the need, they have interconnected one another to make a shift registers. Like if you are going to connect the output of the first D flip-flop to the second flip-flop input, then it will make a 2-bit shift register. Likewise, how much D flip-flops are interconnected, that much shift register is formed. So basically 8-bit shifter is used worldwide. So 8-bit shift register are nothing but 8 D flip-flops interconnected. So there are 4 different types of shift registers. Depending upon the input and output, they are classified. If the input is serial, that means on the first D flip-flop the input is given and the input is taken at the last flip-flop, then it is serial in, serial out. So if the input is given only on the first flip-flop and the outputs are taken from all the flip-flop like this, then it is a parallel output. So depending upon the input and output, they are classified into 4 types. So for our need, which shift register will be suited for our necessity? Like where you can see it is one input and multiple outputs. That means we are going to send only one input, that is serially. So then we can use only these two types. So here you can see we are going to take outputs as a parallel, not as a serial. So we need serial in, parallel out shift register for our LED array. Okay, next we are going to see how it is possible to program a shift register with the help of Arduino UNO. So to know what is shift registers, we need some of the modules of shift registers. So if you search through Google, you can find many shift registers that are available. So basically the shift register serial in, parallel out will be 74HC595. If you search this IC value, then you can get shift registers from the number of manufacturers. There are different kinds of manufacturers. Depending upon the manufacturers, they slightly maybe vary how they has the pin. So you should download the correct data sheet from the manufacturers. If you are using a shift register from Texas Instrument or any other thing, you should download them from that website. So if you search shift registers in a Google, here you can see it takes too long. So okay, here you can see there are number of manufacturers for 74HC595. You can see Nexperia, Toshiba, Texas Instrument, onsemi, SparkFun. So depending upon the board, you should download their data sheet from these websites. So I am basically gonna explain with the help of the first Nexperia. All are same, but only a slight pin variation may be there. So you should verify with the data sheets. So I already downloaded this data sheet. You can see they contain some simple informations about the pin descriptions. So you can see they have given a general description about the serial in parallel out shift register. They also can be accessed serially as well as parallelly. So there will be a SIPO as well as SISO. So these are the features that can be available in this shift register. It will be supported voltage range from 2 to 6 volt. So you can give a 8-bit serial input and you can get a 8-bit serial or parallel output. So it may be have a 3-stage outputs. So you can directly clear the shift register with the help of some certain pin. They will be given below. So let me see. So here is the functional diagram of the shift registers. Here you can see there is a 8-stage shift register and 8-bit storage register and 3-state outputs. So here the 8-stage shift register will do automatically shifting from one register to another if you send the data serially through this. So for every clock pulse, the data will be shifted from one D flip-flop to other and it will be stored in here. So next it will be latched to a storage registers, but this storage register will give you output only when this clock pulse will enable. Only when you give one to this latch pin, it will enable this 8-bit storage register, that it will latch the outputs, or else you cannot see the outputs here. So basically what are the needs we have done is we need a DS pin to our control and SHCP. SHCP is nothing but shift register clock pulse. So you want to give a clock pulse here. Here you can give a data to this, and this should be enabled when we have completed our output. If we shifted 8 bits here, then if we give 1, the 8-bit will be delivered in this output. So this OA is an output enabler. If you are going to show this output to the external through serially, like you want to send a data serially and take a data serially, then this should be enabled, or else it should be grounded. So here is a normal diagram of this. So DS pin, and this is a D flip flop. This is a clock pulse. The clock pulse are given to all stages of 6 to 8 stages of registers, and you can see a reset. MR is nothing but a reset. So it acts as a master reset. If you give a 1 to this, it will reset 0 to this. It will reset all these D flip flops. So it is a STCP is a clock pulse for the storage register. Only when the 1 is given, then it will output the latch. So here you can see only the clock pulse is 1, the Q will be sent here, and then you want to see the value in Q0, then you need to give a output value of 0 here. If you give 0, then it will be 1 and it will be a 1, so it will enable this tri-state logic. Tri-state logic is nothing but so it will inside it will be a like a switch, it controlled by a 1 pin. So if only when this value become 1, this switch will be allowed to close, then the value will be flown from this end to that end. So depending upon the third state, this tri-state logic works. So like that here, when only the OE bar is 1, then this Q0 will be seen out, or else this Q0 will not be available to us. So we need to give 0 to this because it is a NOT gate. So only if you get 0 here, then it will have a complement value of 1 here, then the 1 will be sent here, then the 1 makes this switch closed and the value flows from here to here, and we can see the Q0 value in the output. So what are the needs? First we need to send a data to DS pin and SHCP. SHCP is a clock pulse. We need to generate a clock pulse to these stages, and MR we don't need, it is a reset. Only when we need some project things we can use the reset. And STCP, when all this data are loaded with the shift registers, then we can give a clock pulse to latch it to the intermediate state of tri-state logic, and when the output enabler is 0, then the value will be seen out. So we need typically 1, 2 and 3 third pin. This pin can be connected to a ground, so it will make a 1 value. So these are the pin descriptions. So Q0 to Q7 and VCC and ground, and these are the pins. So let me move to the programming. So here is a clock diagram. So every clock pulse the data is shifted from one value to another. So you can see the values of, finally the Q7 gets a value 1. So they have sent the value of 1 0 0 0 0. So this 1 is shifted to the last bit. So we want to send one by one the values. So it will take 8 clock pulses to entirely shift the value from DS to LSB. So there is a thing called MSB and LSB in digital electronics. MSB is nothing but a most significant bit. So if you give a 8-bit data like this bit is called MSB, this is called LSB. So you want to send in a particular order to get a correct output. If the shift register support LSB first, you should send LSB first, or else you should send MSB first. So depending upon the right or left shift, you must send the values appropriately. So in our case, we are going to send MSB values first, one by one. Next we want to shift this value and send, shift this value and send, like this in our program. So let me move on to the program which I already done in a wokwi simulation. So I can give this link in a description. You can see and you can understand these things. So these three functions is already discussed in our previous programs, how to initialize our port and configure it as a output, and how to send a value to our output registers. So we have already discussed this in our previous video. I can give a link here. You can see how we are going to use this port as a output or input. So we are going to not going to use the library functions to make our pin as a output or input. So it will make our understanding very much better. So as I said, we are going to give a clock pulse. So we are going to make a clock pulse with the help of these port functions. So we are going to send a value 1, that means it will be a high state. This is high and this is low. So we are going to make a high and low with the help of clock pulse with 500 milliseconds, 500 microseconds. So it will, the on time will be 500 microseconds, the off time will be 500 microseconds. Like this we are going to make a 8 clock pulses to send our 8-bit data into the shift register. So basically we need a clock pulse. So this clock pulse is connected in port C, that means we are connected here. The A0 denotes a port C pin, and we are connected to SIPO, which is a shift register clock pulse. And here it is a latch enable. As I said, we want to send a value of 1 to the shift storage latch. As I explained here, the STCP should be 1, then only this output value will be seen at here. So we are going to make a latch enable as a function, and I have connected here in a port B, and the second pin, this yellow wire denotes STCP, and here connected here, that's only a 0x02. Next there is a shift data. Shift data is a function. We are going to shift values one by one. So I am going to take a value of 0x, this is FF, so you can send any value like 0xCF, like that. So we want to send MSB first. So if I am going to send a value of 0xCF, means the binary representation of CF is nothing but 1100 and 4Fs. So I want to send this value serially. First we want to send the MSB, next move on this remaining bits to the 1 bit, and then second. So first it will send this value 1 into our DS pin. Next, 1 bit right shift, that means 1 0 0 1 1 1 and 0. So next this bit comes here and we are going to send this pin. Like this we are going to send shift like that. We are going to make a loop through this. So we have connected 8th pin as a data pin. So we are going to send a data through this 8th pin, data 3, and we are going to shift that number of times that data. First we want to shift 1 time, 0 time, next 1 2, like that we want to shift. And this 0x80 is nothing but a mask bit. We want to send only MSB and all other bits are 0. So we are going to mask this data value with 8080. So literally we are masking is nothing but if you AND with 1000, then all other bits are 0, only this bit will be consideration. So we are going to check only MSB values. So we are going to not look into other values. So this 7 is to send from through this pin, because port B is nothing but port B will have values from 0 to 7. It is a register, output register of port B. So we want to write the values on this register. So the 0th pin is connected to our DS pin. So we want to have that value in the DS pin. So we are going to, if you send this value as it is, if it is like 10000, it will be 80, but our value must be 1 year. So we want to shift this 80 into 7 times. So we are going to only send MSB. We are going to shift this value and make it is this pin. So then it will be a 1 year. Next, whatever the value we are going to send through the DS pin will be attained here. So that makes the line possible to send a data through DS pin. So we are going to send those temporarily. I have made a temp as a unsigned char to check our value. So you can also directly write here. So next there will be a clock pulse. So it will be run up to 8. So 8 clock pulse. Next, after you get a value, then if you enable a latch enable, then the output will be seen here. So you can see I have written only, this is not necessary. First I have made output port B0. So first we have initially made all the pins as 0. Then I have written a while loop and I am going to shift a data of 0xCF to this shift register. So if you run this program, so you can see C and F. So only these pins. So whatever the DS pin, the value will be sent. You can control 8 pins. So with the help of only one pin, you can control 8 outputs. So this is the use of shift registers. There is ultimate use of shift registers that we are going to see in the next video, which is a 8x8 LED matrix. So how to control a 8x8 LED matrix with the help of shift registers, that can be explained in a detail in the next video. So stay tuned. Thank you.